addition and subtraction with scientific notation. So when we have scientific notations that we are adding together, so let's say we have 2.4 times 10 to the fourth power, and I am adding, let's say, 5.57 times 10 to the third power. When you are adding and subtracting only, not when you're multiplying and dividing, you have to make sure that these powers match. They have to be the same. And you're not going to take this one down to the 3, you're going to make sure you go up to the largest one. So if you had several of them in a row, you had more than 2, you need to check all of the exponents and go move all of them up to the biggest one. So there will be one that you don't move, like I'm not going to move this. So this is still 2.4 times 10 to the fourth. But this, if I need to go one more move, that means I do one more move to the left, and this now becomes 0.557. So I have 2.4 times 10 to the fourth, and then I'm adding it to 0.557, and again 10 to the fourth because I just changed the exponent. So now that they match, I can take these two decimals and add them together. And remember, when you add decimals, you need to line up the decimal points, adding and subtracting. And this is 0.557, and you need to put in the placeholders of zeros when you're adding so that you don't lose the columns when you're adding them. 0 plus 7 is 7, 0 plus 5 is 5, 4 plus 5 is 9. This comes straight down in adding and subtracting. Multiplying and dividing is different. 2 plus 0 is 2. So my new decimal, when I added these two together, is 2.957. And then remember, it's times 10 to the fourth power now. Okay, so this was nice because it added where it still goes into the scientific notation rules where you are only allowed to have one digit, and it has to be somewhere between the range of 1 to 9. And it can include 1 and 9, and it has to be to the left of the decimal point. So one digit here. So it falls in there. So this would be my answer to the problem, the original problem, 2.4 times 10 to the fourth plus 5.7 times 10 to the third. This is your answer to that. Now let's say you add or even subtract, and you get something that either has a 0 here or has a 2-digit number here. And I'll show you subtraction in a minute. So let's add something that is going to go above a 1-digit number here. So let's say I have 9.9 times 10 to the 6th power. And I'm going to add that to 8.7 times, let's say 10 to the 5th. So again, these are not the same. So I need to change the 5th and bring it up to the biggest one, which is the 6th power. So I need to move, so make this a 6th power. I need to move one place because it only takes me one number to get up to 6. If this were a 4, then I would move it 2 places. So this is still 9.9 times 10 to the 6th power. And now this is 0.87 times 10 to also 10 to the 6th power. So now I take these two. So I have 9.9, and again, line them up. You have a 0.87, put in a placeholder of and it has to be a 0, only a 0 when you do placeholders. So when I add it, I get 0 plus 7 is 7, 9 plus 8 is 17, right? The decimal goes here, but this now becomes a 10. So I have a problem because I no longer have scientific notation. I cannot put 10.77 times 10 to the 6th, which is currently what this is. So if I have to make one more move to the left, I am going to add to the exponents. If I end up going this direction, let's say this was just a 0 and I had to go over here, I would actually subtract 1 from here. So this one I have to go to the left because I can only have one digit, then the decimal. I need a 1.077. And because I added one more move, this is now the 7th power. And this would be the answer to this original problem. So if you are subtracting, let's go to the back here. So if you are subtracting numbers, let's say you had, and some of them on your sheet are going to have negatives. So let's go ahead and do one of those. So number 13 on there. So 5.1 times 10 to the negative first power. Plus, and now there's an issue here because this technically is not in scientific notation, and we're going to put it in. So I actually have a problem here because there's a 0 here and there's not supposed to be. So I need to change this one because this is not going to be the fourth power. So I need to lose a move. So I lose a move when I go to the right. That means this becomes a 3. So now my problem should be 5.1 times 10 to the negative first power. And then I'm adding 3.8 times 10 to the third. So I need to bring this guy up to a third. So I have to add, so think about the number line, -1, then 0, then 1, 2, 3. So I need to add 4 numbers. So I get to 0, then to 1, then the 2, then to 3. That's 4. And when I'm adding moves, I'm going to the left. Let me move this over a little bit so we can see. So I'm adding 1 move, 2 moves, 3 moves, 4 moves. So now my decimal is here, and I have 1, 2, 3 placeholders. Remember, those are zeros. So now I have 0.00051, and I'm now, remember, I need to be at the third power, times 10 to the third power. Okay, and then I still have 3.8 times 10 to the third. Because this is not scientific notation if you have a 0 here, so we need to put it in there. Okay, so it's a little deceiving, but it is number 13 on the sheet that I gave you. All right, so now we have both of these the same, so we need to add them together. So we have a 0.00051 and then a 3.8. So the 3 is here, 0.8, and then we need to put in 1, 2, 3, 4 placeholders. Now, if you're having trouble keeping your column straight, my recommendation is to get a piece of graph paper and put one number in each box as you're doing it, and it'll help you do that. Same with long division. It'll help you keep your column straight. Remember, I'm adding. So I have a 1, I have a 5, I have a 0, I have a 0, I have an 8, this straight down, and a 3. Okay, this is now my new number. And remember, it's times 10 to the third power. Now, what you want to do when you're looking at scientific notation with this, so let's go back to the original number up here. So originally we had 5.1 times 10 to the negative first power, and we had a 0.38, a 0.38 times 10 to the fourth. Okay, so what is this really? Well, remember, you're going left 1 space to get it back into standard. So this is really 0.51. We're going to put a 0 here. Okay, and then this is really, I need to go to the right 4 spaces. So 1, 2, and then 2 placeholders. So this is really plus 3,800. So if you look at this, this will be 3,800.00. And it comes out to be 3,851.51. So like $3,800.51, if you want to look at it that way, is how this would go. And that's what this is. So let's move this decimal. So this was our answer, 3.80051 times 10 to the third power. If I go and I put it into scientific notation, I go to the right 3. 1, 2, 3, my decimal point would go from here to here, and when you just added these numbers straight, that was what you got. So that's how it matches. Okay, let's do subtraction. All right, so if we subtract, let's do one here. I'm just gonna make one up because those have a lot of negatives. Let's not deal with negatives right now. All right, so if I have, let's say, 1.2 times 10 to the third power, and I am subtracting 3 point, let's see, no, I need to do a 9. Let's do a 9. So 9.6 times 10 to the first power. Okay. All right. So I need to get this one up to the third power. So I have to I need 2 more moves to get this to the third. So 1, 2. So this one is 1.2 times 10 to the third. And then I'm subtracting 0.096 times 10 to the third. Okay, so now that they're both there, both 10 to the third, I'm subtracting. I take these two. So I have 1.2, and then I have 0.096. Put in my placeholders, but pay attention to the sign because you might go the wrong way with this. So a lot of borrowing. I borrow from the 2, make it a 1, this becomes a 10, but I need to borrow again. Now I have a 9, now I have a 10. So I have 10 minus 6, which is 4, 9 minus 9, which is 0, 1 minus 0, which is a 1, and 1 minus 0, which is a 1. Okay, so that means that my answer is 1.104 times 10 to the third power. Okay, if we are, let's stick on the back of this one. And let's say we end up with let's do 1.2 again. And then if I subtract 1.1. Okay, let's say we had both of these that were the same power. So I want to show you something here with this. So we have the same power. So we have to do 1.2 minus 1.1. And we subtract that, we get a 1, but we get a 0. We cannot have this. So this is what I was talking about where you have a 0 here. And let's say that this is where you got it to. Okay? I need to lose a move. If I move to the right, I'm losing a move. So now I have 1 or 1.0, but I need to lose a move. So now this is times 10 squared. And if you're getting confused or not seeing this, what you could do is make these into standard so that you see it. So this was times 10 to the third power. So we go 1, 2, 3. So this is 1200. And then this was 1, 2, 3, and this is 1100. You're left with 100. And if you put it back into scientific notation, remember the dot is here, it needs to go here, 1, 2. So you have 1 times 10 to the second power. And that's what we got. So if you need to put them out for yourself and do the math to see it, and then put it back into scientific notation, to see if you got it right, you can also check yourself that way.